This video is sponsored by KiWiCo. As you probably know, I created a couple of projects about wireless audio communication over the years. And the newest one were walkie-talkies, for which I firstly tried using an nRF24 for the wireless communication parts. But that turned out to be a total disaster. So next I used generic RF modules in order to transmit my voice through the air, which worked out quite a bit better. Nevertheless though, my main point here is that both of those approaches require lots of components and good electronics knowledge, so they are kind of complicated. But why not just keep it simple for a change, and think back to the good old times in which we used such old school radios for getting information through the air. In my case, I want to keep it as simple as possible by focusing on AM radio communication, which stands for amplitude modulation. But why is that simpler than FM, you might ask, which by the way stands for frequency modulation? Well, as a practical example, my radio in AM modes can pick up when I'm turning on my lights. So creating a suitable signal with a transmitter should not be too hard if a simple light switch already sends something similar out. And when it comes to AM receivers, then you can find builds on YouTube which only consist of a coil and a diode. And they work. So how hard can it be to create something a bit better? Well, we're about to find out in this video, in which I will do a couple of circuit experiments in order to ultimately show you how to create a simple but functional AM transmitter and receiver. Let's get started. First off, since I already got an AM receiver to work with, let's rather focus on the AM transmitter for now. Before that though, we need to understand what kind of signal we have to send out. An AM signal basically consists of a carrier sine wave, which gets modulated by an audio signal, which can be for example music or my voice. But to keep this example simple, it will also be a sine wave for now, just with a lower frequency than our carrier wave. And according to the label of my radio, the carrier frequency should be between 520 kHz and around 1.6 MHz. Now simplified speaking, the process of amplitude modulation increases or decreases the amplitude of our carrier wave according to the amplitude of the audio signal. Thus, the send-out signal could look something like this, and it contains all the information of our original audio signal, which can then be extracted at the receiver station. So obviously, we need some kind of oscillator circuit that creates a suitable carrier wave that we can then modulate with firstly a function generator for testing, and afterwards with a microphone circuit. And the first component that came to my mind when hearing oscillator was the 555 timer, which according to my comment section can be used for pretty much everything, so an AM transmitter should not be a problem. And thus I found two rather popular circuit designs for an AM transmitter with it. Like usual, the 555 timer creates a square wave with specific on and off time and thus frequency according to these two resistor values and this capacitor. The first design, however, uses the CV or control voltage pin to smuggle in our audio signal, while the second design uses the reset pin for that. But when we think about the internal structure of such a 555 timer, which you can learn all about by watching my video about the topic, then it should be clear that the audio signal will not amplitude modulate the carrier wave, but instead only change the on and off times and thus the frequency. So I almost didn't feel like trying out these circuits, but since they were so simple, I wanted to give them a try anyway. And after making sure that the carrier signal was created without a problem, I hooked up my function generator to firstly the control voltage inputs and saw something like this on the oscilloscope. As suspected, the audio signal does only alter the frequency over time and not the amplitudes. But just for fun, I added a 1 meter long antenna to the output of the circuits. And surprisingly, after tuning the radio, the audio signal was picked up just fine. Listen. Now of course, we could also utilize the reset pin of the 555 timer, which, as you can see on the oscilloscope, creates a similar but a bit worse modulation that can be once again picked up by the radio. So next, I grabbed my small microphone amplifier boards, which I created in a previous video, and hooked it up to the 555 timer according to this schematic. And here's how my transmitted voice sounds like.
As you can hear, the audio quality is pretty terrible, which means we should probably come up with a proper AM circuit.
The simplest solution I found for this was this function generator kit based around the XR2206 IC. You can get such a kit for around $8, and on its outputs it can create a sine voltage with an adjustable frequency that is perfect for our AM signal. And to modulate it, all we have to do is to feed pin 1 of the IC, which is coincidentally called amplitude modulating signal input pin, with our audio signal. So I connected the mic amplifier output to the pin through a 3 microfarad capacitor for decoupling, added the antenna, tuned the frequency to 1 MHz, and selected the channel on the radio.
And as you can see on the oscilloscope and hear through the radio, the AM transmitter seems to work perfectly fine. And now that we got a functional AM transmitter, you might be asking yourself if that is even legal.
Well, since there still exist AM stations around the world, you should definitely check your local law. But since my design is pretty low power and the antenna design is certainly not optimized at all, we should be just fine. And that brings me to a homemade AM receiver, for which I got myself this TA7642 IC. But finding a proper datasheet for this old IC was not easy, but eventually I found this. It seems like the IC consists of a couple of transistors, which not only amplify our received AM signal, but also demodulate it. That means that according to the application circuits, we simply have to build up an LC resonant tank circuit, whose resonance frequency is close to our AM signal. And then the IC should simply spit out the amplified signal on the outputs. And if you're now wondering what an LC resonant tank circuit is, then make sure to watch my video about oscillators. But anyway, for the homemade coil, I used this 10mm thick iron rod, around which I firstly added a scotch tape barrier to prevent eventual shorts of the enamel copper wire. For that, I used this 0.35mm one, which I wound around the rod for approximately 100 turns. After then protecting the coil with another layer of scotch tape, I sanded off a part of the varnish and measured the inductance of the coil, which was around 360 microhenry at 1 kHz. So with a capacitance value of 100 picofarads, we should get a minimum resonance frequency of around 840 kHz, which hopefully should work. So I searched for a suitable trimmer capacitor, and of course eventually found one. That means it was time to solder all of the required components to one another according to my slightly modified schematic. As soon as that was done, I powered the circuit with 2 volts and connected my oscilloscope to the outputs. And as you can clearly see, we received something that looks awfully similar to our transmitted audio signal. But to be certain, I had to hook up my recorder to the receiver outputs. And here's the final result of my AM experiments.
As you can hear, my receiver seems to work just fine with my transmitter, which ends my AM adventure for now.
Now of course at this point you could hook up an audio amplifier to the receiver to, for example, connect headphones. and luckily KiWiCo just sent me over one of their crates which contains just that. Now, in case you do not know, KiWiCo can send you monthly crates with DIY kits that are designed around STEAM, aka science, technology, engineering, art and mathematics. They are made not only for kids, but pretty much every age group, because let's face it, who doesn't love building something on their own and understanding how it works along the way? All crates come with everything you need to build the projects. And the best thing is that you can have a look in my video description and use the link there, kiwico.com/GreatScott, in order to get a 50% discount on your first crate order. And do not worry, they not only ship inside the USA, but to plenty of other countries around the world as well. So feel free to have a look for yourself. And with that being said, I hope you enjoyed this video. And I hope I maybe inspired you to try the circuit out on your own, because it is certainly a fun learning experience. As always, thanks for watching. Don't forget to like, share, subscribe and hit the notification bell. Stay creative and I will see you next time!